The story of the interstellar comet known as 3I/Atlas reads like a rare cosmic drama unfolding on a timescale that humanity can briefly witness but never repeat. This extraordinary object, often described as an intruder from parts unknown, is not merely another comet looping around the Sun on a predictable path. Instead, it is a true galactic traveler, born around another star and flung across the vast emptiness between stellar systems long before Earth itself took shape. Its appearance in our skies has given astronomers a fleeting but invaluable opportunity to study material from beyond the solar system, offering a direct physical connection to regions of the Milky Way that otherwise remain inaccessible. 3I/Atlas was first detected in late June by the NASA-funded Atlas Survey Telescope located in Rio Hurtado, Chile, a facility designed to scan the skies for fast-moving objects that could pose a threat to Earth. Almost immediately, scientists realized that this object was behaving very differently from typical comets bound to the Sun's gravity. Its trajectory was unusually steep, its velocity far too high to be explained by an origin within the solar system. By July, careful analysis confirmed what astronomers had suspected. This was the third known interstellar object ever discovered, following the enigmatic 1I/Oumuamua in 2017 and the more traditional, comet-like 2I/Borisov in 2019. Each of these visitors has been unique, and 3I/Atlas has quickly distinguished itself as the most visually dramatic and scientifically rich of the trio. Traveling at an estimated speed of about 130,000 miles per hour, or roughly 210,000 kilometers per hour, 3I/Atlas entered the inner solar system from the general direction of the constellation Sagittarius. Its immense speed alone speaks to its alien origin. Objects born within the solar system simply do not move this fast unless they are being violently ejected. As it plunged inward, the comet passed through the region of space occupied by the planets, drawing intense attention from observatories around the world. Its closest encounters with Mars and the Sun occurred in October, marking a period when solar heating dramatically altered its appearance and activity. On October 30th, 2025, the comet reached its closest approach to the Sun, passing at a distance of about 130 million miles, or 210 million kilometers, just outside the orbit of Mars. This moment, known as perihelion, was critical. As the comet's icy nucleus absorbed increasing amounts of solar energy, frozen gases locked within its structure began to sublimate, transitioning directly from solid ice into gas. This violent process released enormous quantities of dust and vapor into space, forming a luminous coma around the nucleus and feeding a growing tail that streamed away from the Sun under the pressure of solar radiation and the solar wind. For scientists, this activity is a treasure trove of information, revealing clues about the comet's composition, structure, and history. Now, as 3I/Atlas races outward once more, it is approaching its final major milestone within reach of Earth-based instruments, a relatively close encounter with our planet on December 19th. While the term close is purely astronomical, the comet will still be about 170 million miles, or 270 million kilometers, away, nearly twice the average distance between Earth and the Sun. This moment represents the best and last chance to observe the interstellar visitor in detail before it fades into the darkness forever. After this flyby, the comet's hyperbolic trajectory will carry it irreversibly out of the solar system, never to return. Recognizing the significance of this fleeting opportunity, space agencies around the world have turned some of their most powerful instruments toward 3I/Atlas. Spacecraft and observatories operated by NASA and the European Space Agency have been collecting data across multiple wavelengths, from visible light to infrared, capturing the comet's evolving behavior as it responds to solar heating. In early December, both agencies released new images that vividly demonstrate just how active the comet has become since its passage near the Sun. These observations confirm that 3I/Atlas is not a dormant relic, but a dynamic, jet-spewing body undergoing intense physical changes. One of the most striking images was released by NASA on December 4th, captured by the Hubble Space Telescope. Photographing such a fast-moving target is no small technical challenge. To keep the comet sharply in view, Hubble's camera had to track its rapid motion across the sky rather than remaining fixed on the distant stars. As a result, the background stars appear as elongated, ghostly streaks, emphasizing the comet's extraordinary speed. At the center of the image, the comet itself appears as a bright, glowing point, marking the location of its nucleus, surrounded by a diffuse, luminous coma. The coma is a defining feature of active comets, forming when sunlight heats the nucleus and releases gas and dust that expand outward into a vast, temporary atmosphere. This material is then shaped by solar radiation into tails that can stretch for millions of kilometers. In the case of 3I/Atlas, the Hubble image faintly reveals not only the broad coma, but also subtle jets of material erupting from the sun-facing side of the nucleus. These jets are of particular interest to scientists because they can reveal localized regions of activity and provide insights into the internal structure and composition of the comet. Comets brighten naturally as they approach the sun, but the behavior of 3I/Atlas carries additional significance because of its interstellar origin. The ice is locked within its nucleus, likely formed around another star, under conditions that may differ significantly from those in the early solar system. By analyzing the light reflected and emitted by the coma and tail, astronomers can identify the chemical fingerprints of these ices, comparing them with those found in solar system comets. Such comparisons may help answer fundamental questions about whether the building blocks of planets and life are common throughout the galaxy or whether our solar system is chemically unique. Beyond its scientific value, 3I/Atlas has captured the imagination of the public in a way few astronomical objects do. The idea that a massive ancient snowball from another star system is passing through our cosmic neighborhood, briefly illuminated by our sun before vanishing into interstellar space, resonates deeply with our sense of curiosity and wonder. It is a tangible reminder that the solar system is not an isolated island, but part of a dynamic, interconnected galaxy where material can be exchanged across unimaginable distances and timescales. As the comet continues its outbound journey, it will gradually dim as solar heating decreases and its activity subsides. Eventually, even the most powerful telescopes will lose sight of it, leaving only data, images, and memories behind. Yet the legacy of 3I/Atlas will endure. Each interstellar visitor expands our understanding of the galaxy and sharpens our tools for detecting the next one. Future surveys, more sensitive and more comprehensive, are likely to reveal that such wanderers are far more common than once believed. In the end, 3I/Atlas is more than just a spectacular astronomical event. It is a messenger from another part of the Milky Way, carrying with it the history of a distant stellar system and offering a brief glimpse into the broader processes that shape planets, stars, and galaxies. Its departure marks the closing of a rare observational window, but it also opens the door to new questions and new discoveries. Long after it has disappeared into the void, the data gathered during its fleeting visit will continue to inform and inspire, reminding us that even in the vastness of space, moments of connection are possible, if only for a short while.